Unit 1, Level 3, Lesson Topic Number 1. Model integer multiplication on the number line. In this lesson, we will answer a very important question. How does modeling multiplication on the number line help us understand the rules for multiplying integers? Oftentimes, we are given the rules for multiplying, things like a negative times a positive equals a negative, and in the strangest case of all, a negative times a negative equals a positive. And we're told to memorize these rules and use them whenever we are completing integer multiplication. But there is actually a very good reason for why a negative times a negative is a positive, even though it seems very strange. This lesson will explore the rules for integer multiplication and demonstrate why they are true on a number line. Let's begin with a brief review of multiplication.
I am going to explain how to write a multiplication equation to represent illustrations by counting the number of equal groups and the number of objects in each group. Multiplication is finding an unknown total or product. What we do know are the factors or the number of groups and the number of objects in each group. Take a look at the images below. Here we have 5 plates of 4 cookies. To find out how many cookies we have in all, we will multiply. But what numbers or factors will we multiply with? We will multiply the number of groups, in this case, number of plates, and the number of objects in each group, or the number of cookies. These will be our factors. To find out how many cookies we have in all, we will multiply. Here we have 1, 2, 3, 4, 5 plates or groups. And each plate has 1, 2, 3, 4 cookies. So there are 4 objects. Therefore, our factors are 5 and 4. We can count the number of cookies in all to solve 5 times 4. And if we do that, we find out that 5 times 4 equals 20.
So we see that the definition of multiplication is adding equal groups, also known as repeated addition. Please make sure you're writing this down on your notes. Example 1. So how can we take this idea and apply it to a number line? Remember that when we are adding equal groups, that means that each group has the same amount. So for example, in this problem here, we see 3 plus 3 plus 3 plus 3 plus 3. Each group has the same amount. So this first number is one group of 3. But we don't have one group of 3, we have 5 groups of 3, each one having the same amount. So another way to write this repeated addition is 5 times 3, 5 groups of 3. Now I know this is review, but I wanted to show it to you so that you can see how we're going to apply it now to the number line. When you set up your number line, the easiest way to do it is to set it up by the group size. So if each of your groups is worth 3, on the number line, you would want to skip by 3s. So that means that each space here represents one group of 3. Then, if you think about the idea of 5 groups of 3, first, when you're multiplying, you always start at 0. And then we're going to represent 5 groups of 3. Since 3 is positive, we move to the right 5 groups. And again, each space is worth a group, because each space is worth 3. So I move 1, 2, 3, 4, 5 groups of 3, and I land at 15, which we know that 5 times 3 is 15. Pause the video and try this example on your own. Then come back to the video to review the problem. Example 2, model 6 times 7 on the number line. 6 times 7 means that you have 6 groups of 7. Remember, the first factor is the number of groups, and the second number is how many you have in each group. So another way to write 6 times 7 is 7 added 6 times. 1, 2, 3, 4, 5, 6 of them. When you set up your number line, since each group has 7 in it, you want to set up your number line to skip by 7. That means that each space is one group of 7. Then, again, you always start at 0. And since we have 6 groups of a positive number, 6 groups of 7, we move them to the right. So again, 1, 2, 3, 4, 5, 6 groups of 7, and I end at 42, and we know that 6 times 7 is 42. If this was all there was to it, we really wouldn't need to show this on the number line at all. We have other ways to represent positive multiplication, and as you saw in the video, for example. But when you start to throw negative numbers into the mix, it makes things a little more complicated, and using the number line will help us explain the rules for integer multiplication. So let's look at another example. Model 5 groups of -3 on the number line. In this case, we have 5 groups of -3, and that changes things because that brings the other side of the number line into play, which is how we're going to explain the rules. Now, if you know the rule, you know that a positive times a negative equals a negative. Why is that true? It has to do with what's inside the group here. You have 5 groups of -3. That means I'm adding -3 5 times, right? -3 plus -3 plus -3 plus -3 plus -3. So when I graph that on my number line, there are -3 in each group, so I set my number line up by 3s, so each space is worth a group, and then I start at 0. But think about it. If I'm adding groups of -3, think back to how we would represent that on the number line. You would go, if you were adding a negative, you go to the left, not to the right. So in this case, I would start at 0 and move 5 groups of -3. So to the left, -3, -6, -9, -12, -15. If the number in the group is negative, you have to go to the left. So that's why a positive times a negative equals a negative. And in this case, we end at -15, and we know that 5 times -3 equals -15. But what about other kinds of negative problems? Let's take a look at a couple. And let's pause for a minute and define a very important word that's going to be relevant when we're writing these on the number line. Opposites. What are opposites? I'll give you an example. 5 and -5 are opposites. And the reason they are opposites is that they are 2 numbers that are an equal distance from 0 on the number line. Here they are. Here's 0, and the definition of opposites are 2 numbers that are an equal distance from 0. Here. Right, so 0 to 5, that's 5 units, and 0 to -5 is 5 units. They are opposites. This idea of taking a positive number and its opposite is a negative, meaning it's on the other side of the number line, is very key to understanding the rest of the rules for integer multiplication. Let's look at this problem. Model -7 times 12 on the number line. Remember that another way to say the word negative is opposite. And again, recalling that opposites are numbers that are on opposite sides of 0 on the number line. So -7 times 12 is read the opposite of 7 groups of 12. Well, think about it. If I start at 0 and I have the opposite of 7 groups of 12, that means that each group contains 12. So I set up my number line by 12s, right, in both directions. And if I were just doing 7 groups of 12, I would count to the right. But I'm not doing that. I am moving the opposite of 7 groups of 12. If 7 groups of 12 goes to the right, the opposite of 7 groups of 12 goes to the left. So again, I would go to the left. 1 group, 2 groups, 3 groups, 4, 5, 6, 7. 7 groups of 12. And I would end at -84. So again, a negative times a positive is a negative, because the opposite of 7 groups of 12 would be negative 84. You go in the opposite direction on the number line. Finally, let's look at the most confusing idea of all, that a negative times a negative equals a positive. Why does that work? We can prove it with this example on the number line, using the idea of opposites. So think about it. Negative 4 times negative 8. That means if I have a negative in front, that's the opposite, right? So I have the opposite of 4 groups of negative 8. So each of my groups contains negative 8. I set up my number line to skip by 8s to the right and to the left. And again, I always start at 0. And I'm going to move, again, because this is a negative 4, I'm going to move the opposite of 4 groups of negative 8. So think about it. 4 groups of negative 8 would mean I would go to the left, right? Because the negative direction is to the left. 1, 2, 3, 4. But if I'm going the opposite of 4 groups of negatives, the opposite of a negative is a positive. So the reason that a negative times a negative is a positive is that on the number line, you are moving the opposite direction of negatives. And the opposite of a negative is a positive. So it looks like this. We move the opposite of 4 groups of negative 8. Again, moving negative groups would take me to the left, but the opposite of that would take me in the positive direction to the right. So I have my groups. 1 group of 8, negative 8, 2 groups, 3 groups, 4 groups, and you end at 32. This is why a negative times a negative is a positive. You are moving in the opposite direction of a negative on the number line. At this time, we are at the end of the lesson. You need to complete your summary, which should answer the essential question. So the essential question was, how does modeling multiplication on the number line help us understand the rules for multiplying integers? So what I want you to do is to go back through the examples and try to explain. If you can't explain in general, at least explain for these problems. Why is a negative times a negative a positive? Or why is a negative, for example, why is a negative times a positive a negative? Try and explain the examples and how it works, how it relates to the number line. Remember, your summary should be 4 to 5 sentences. They should define the vocabulary. There were at least 2 vocabulary words in that problem. You should give examples and make sure you answer the question thoroughly.